is recursively.
कैसे हैं आप?
भाई बढ़िया सर. So
Nice.
always we think of you whenever I pass through some kind of a big statue, no? तो पहले आप याद आ जाते हो.
Nice. Thank
Yeah,
you so much.
yeah,
Thank you.
yeah. So good. So we'll see you in a few minutes, sir.
Yes.
Yeah.
Yeah. Looking forward.
Shreya? Yes, Shreya. We can start the event now. Over
Yes,
to
sir.
you. Yes.
A very good afternoon to everyone. My name is Shreya, pursuing master's degree in computer-aided structural engineering at IIIT Hyderabad. I feel honored to extend my warm welcome to everyone present here. On behalf of IIIT Hyderabad student chapter at Earthquake Engineering Research Center, I would like to take this opportunity to welcome our honorable guests, all the participants from the academia, industry, and research fraternity to this webinar on the topic Structure as Architectural Interposition. And on the occasion of Engineers Day, I extend my heartfelt wishes to all the engineers present here. May we build, innovate, and contribute to the growth and betterment of the society. Happy Engineers Day to all. Now, proceeding further, I would like to introduce our keynote speaker for the day, Dr. Architect Engineer SP Anchuri, Chief Consultant of Anchuri and Anchuri firm, to our esteemed audience. Our speaker is a well-known architect and structural engineer with a triple graduate and triple postgraduate from reputed institutions in civil engineering, architecture and architectural engineering, business administration, structural engineering, and concrete construction management, respectively. He has a PhD in structural engineering from JNTU Hyderabad. He is actively involved in research work on integrating architecture and structures to achieve optimized forms for efficient tall buildings. He is currently the chief consultant of Anchuri and Anchuri firm, a 25-year-old consultancy firm having offices in Telangana and Andhra Pradesh. He designed more than 1,500 building projects with an integrated architectural and structural design approach and was extensively involved in group housing. He's a professor affiliated to JNA FAU and a member of the board of studies for various universities and institutions. He has guided more than 150 UG and PG students in their architectural practical training and thesis works. He has published number of articles in newspapers and magazines and presented more than 150 technical papers at national and international conferences, seminars, and workshops. He is an energy conservation building code expert and a consultant. He is passionate about implementing new technologies by integrating multidisciplinary collaborations using traditional and regenerative design approaches, taking knowledge to humanity. This was the introduction of our speaker for the day. Now, before we start the event, there's a small announcement for all the participants. If you have any questions, doubts, or clarifications, please do type your queries in the chat box only. We will have sufficient time for the discussion at the end, where Dr. P. Praveen Kumar Venkat Rao, Faculty Advisor of Student Chapter, will be the moderator. Now, without any further delay, we will turn the time over to our speaker. Sir, over to you.
Thank you. Thank you for such a wonderful introduction. So let me share my screen
Yes.
first, then I will.
Right.
Yes.
Yes, sir. Your screen is visible, sir.
Screen is visible now.
Yes. Yes.
But it's not full screen, you know. It's
But yes, sir. It's not in full screen, but still, it's fine. No problems.
shall I try or will we go for it?
No. We'll go further, sir.
Okay.
Okay.
Right. So, namaste, everybody. In fact, it's one day before the Engineers Day. So, wish you happy Engineers Day to everybody. So, we have different cross section of the industry as participants. Maybe few will be joining, but right from Anuradha Reddy Garu to Mr. Abhay, cross section of entire different domains we have. So that's what is, wherever the structure is there, wherever the architecture is there. So I wanted to, in fact, talk something about the structure as architectural interposition, because, we have a lot of times, say, confusion in between, but this basically, this presentation is made mainly for the students of, or those who are in the, research work of structural engineering, predominantly. But we'll try to understand how the things go. But we know, friends, this is the season of webinars, and the reason behind this particular topic is to create fusion between architectural and structural fraternity, to clear out some kind of confusions, which normally we come across several times. So how this goes, parallelly, or let me try my level best to make you understand about this, because I work on the same field since long, and when it comes to, let me change the slide. See, first of all, I would like even to thank IIIT Hyderabad and Indian Association of Structural Engineers, and IIIT Hyderabad student chapter, who has given me opportunity to talk to you, share my views, because I started my life in the 20th century, and now we are in 21st century. There is a gap of 25, 30 years. Definitely, there is a generation gap. That's why I wanted to see, when we started, the heroes were their next generation came, and now we are viewing that there is a drastic change, right from cinematography to writing to everything. So I feel every project is like some kind of a theme where all people are involved in the making one movie. That may be director, producer, writer, technicians, and everybody. It's a very integrated thing. Not even single. We can leave it. So here, even in the buildings, we need to have that entire integration. And when I started my practice or the field about 25 years back, the average clientele or those people involved in the process or occupants or ownership were about 50 plus. But this generation, we have 50 plus practitioners, and then I am 50 plus and my client is about 25 or 26. So they have a different mindset. So how that really goes, because the space today we'll be talking more about the built environment or the buildings, where the occupants' comfort, occupants' requirement is the priority. That may be the machine-centric, or the human-centric. So we need to understand how the things go about. And anything goes wrong, I think Mr. Praveen, Dr. Praveen is responsible. Friends, the nature's power and the capability to regenerate, what you are seeing on your screen is a cabbage leaf palm in the National Park of Australia, when it got burned. So this picture was taken about 3 weeks later. You can see how, again, that is greeny. So the forest, it's entirely nature which really comes back, it regenerates. So there are two different aspects of the built environment. One is architecture, and the other is structures. There, I think regenerative architecture with generative structures is the need of the hour, because the transition from conventional to the regenerative design is important, and the current practice is between the green and sustainable, but we need to reach, we need to have the aim of living system design. So post-pandemic, you have seen how the requirement is changing. We need to have a living atmosphere. So more than a technical or more than just a mechanical, we need to understand that. So human-centered towards nature-centered design is the need of the work, and we need to understand that and how this interposition helps us to go further. I think we need to understand. But we are in a different trap now. We are in a very, very different trap at present. We started with the telegrams, but today the telegram is entirely different. At that time, we had slide rules. I don't know, Mr. Abhay Gupta started with slide rules or earlier. I have not seen that, in fact. So, but today there is no rule at all. Without rules, we are doing everything. So we are having one side artificial intelligence and
ये
another
टॉपिक क्या है रे पहले?
other side we have this human intelligence, but natural intelligence is also very important. We must understand the difference between the evolution and the revolution, or otherwise we will see the pictures how those things are developed on the realistic thing. So we need to understand the reality and reality. And you can see these pictures which were developed on the basis of the inputs given by the practitioners or designers. So these were developed long back. And the people from Romania and Tunisia. So there is no, as such, the small country or big country or where it's located, but the universal, everybody is going ahead with this usage. But we must understand the complexities, the requirements, and we need to have some kind of a sustainability towards the approach even. So these things, it can be in any field, in fact, right, from the medical, you might have seen recently, one of the telecom, they announced in every field, that may be agriculture or industry or medical or architecture or engineering. So this is going to be a next, live about building information modeling and all. That's going to be a very common phenomena. But the artificial intelligence, how it's going to come and how it's going to take over the entire thing, that we need to understand. So it's a very, very important thing to understand how that particular integration that goes ahead of us, then we can't catch. It's a very difficult thing. So to come to this stage, we have taken about 2 lakhs years. How the human evolution we started, say about 2 lakhs years back, the Homo sapiens started to evolve and even started migration. There about 40,000 years back, the paintings were seen in the caves. So 12,000 years back, the large food production started, and about 6,000 years back, the invention of the cities happened, and the 400 years back or so, we had a mass production of the goods and services. Today, we are in a different mode. 200 years back, technology with electricity, but today we have everything e-logistic, everywhere. The evolution, it's a e-evolution today, but we have the challenges. But basically, when you go back, you can see one temple, which is about Tanjavur. It was about 11th century. The great Chola king Raja Chola, who built this. And just see who were there. The Agam Shastra was on peak, and then how the construction. Today we are talking about the technologies, material, and all. But can you imagine? These things were beyond imagination. So there was no gadget, there was nothing but the master builder, the passion, the skill, the interest, everything was different. So we need to understand, we need to take a lot of things from the heritage and ancient buildings, which will help us to go, in the future with the latest things available, the contemporary, but with the heritage. So the scope, size, and design of our living habitats, we started about 25,000 years back. Some kind of a painted caves, as I said. Now today we are in the buildings which are printed. These are 3D printed buildings where there is no form required. The days are not far away. You can print a statue, you can print building, you can print anything. So which that with the the moment you think it can go to the machine and then it can start printing, and within less time you get it, and then naturally the challenges are there. We should be more attentive when these things are coming. So one way we are talking about reaching to the Mars, and the other thing, we don't have common normal drainage system in front of our house. So there is a contrast. We need to balance that thing, and we need to go for a different kind of a world together. But coming to the architecture, friends, for me, the architecture is the art and science of designing buildings and other physical structures. And when it comes to the structure is an integral part of designing architecture. No doubt, the synergy between structure, form, and architecture makes the space creation structurally strong, stable, functionally optimized, and aesthetically pleasant. So we need to understand the structure. Now, when you talk about civil engineering, when you start about the basic first year to the PhD level, so we need to understand the element, right from the elements to the object. So normally in UG level, we normally disintegrate the parts of the object, and we try to learn each element, and then by the end, by the time we come out, we try to assemble things, and how to make that object is very important. So then that really the life cycle starts right from the planning, designing, execution, operation, and maintenance. So based on the types, structural systems, forms, that may be one-dimensional, two-dimensional, three-dimensional, or the application of material or elements, we have various types of structures. So what you will be normally learning in the, your syllabus, and then when it comes to the analysis and then design and then how it will be made, that depends on this entire process. But for me, as an architect and structural engineer, the form is in between. In fact, when the dot travels, it becomes a line, and when the line travels, it becomes a plane or surface, and when the surfaces or planes are coming together, then that is created a volume. That may be a building enclosure. When we are talking about the building, I'm talking about the floor, I'm talking about the sides, I'm talking about the roof. Then we need to have fenestration based on the functional requirements. So friends, the five elements like Mahapanchabhutas in the nature, the feasibility is the starting point of the project, functionality is the space used for what, the technology, engineering of buildings, which has endless options, and the sustainability, that's the need of the hour, and the innovation, the design, shape, and construction. But friends, for me, the correct is beauty, but beauty is not always correct. We must understand this, and because only aesthetics is not correct, only the stability is not correct. We need to have everything there. I think we need to have interposition, and these are very few projects which I could be involved in. So just to have different ideas, I'm just showing it. So here, different types of buildings are there where we did integrated design. Individually, we will architects and the structural engineers we did for some architectural projects, and some expertise like say energy simulation or some kind of optimization of or creating that particular, converting that particular building into energy efficient or efficient things. Partial involvement in that in terms of facade, in terms of geotechnical, in terms of landscape, and it's a group, and it's a integrated design approach. So based on the scope, we had our service in these projects. So here there are different kinds. And even when it comes to the mythological parts, and this was one of the favorite project, and my entire family was involved. This is called as the Rama Narayanam, which is situated in Vijayanagaram. It's a different theme park where the structural engineering, geotechnical engineering, building services, the methodological, Agama Shastra, all where, because where the Pathshalas are there. It's not a school which is a modern engineering college, but there we have the saints and other. It's a different type of school and a Gurukul. So a lot of things go here as an integration. So that we learn a lot of things from this particular project we did about 20 years back. Now, friends, the design is to design a design to produce a design. So here, the design is the ability to imagine that which does not yet exist, to make it appear in a rigid form as a new, purposeful addition to the real world. So designing is to initiate change in man-made things. So here, I will start with the very, very basic elements because we all are structural engineers here. We know right from the bending moment, shear force, torsion, and all deflections and other things in a different side of the coin. But basically, how the thinking process starts in the architect's mind when he starts creating something, because everything is mathematics, whether it's a calculation, whether it's a creativity, or putting any line. So here, the integral components used in the creation of design, one must understand. Even you are not involved in the design process of architecture, but you need to understand how the process starts, because that starts on the paper or from the mind. It's a brainchild. So it's a, even though all are involved, that starts through the mind of an architect. So he thinks of line, space, color, texture, form and space, and the value, and how that impacts. Definitely it impacts. So something is vertical, represent the dignity, formality, then stability, and then strength. If something is horizontal, we feel that it's a calm, peace, and having relaxation. And if something is a diagonal, then it represents the action, activity, excitement, and movement. And the curve, which gives the freedom, which are the normal and naturals, and then that appears like a soft and soothing to the mind. So really this happens? Yes, surely. Even if you wear some kind of a shirt, if you are having a horizontal line shirt, then you will see some kind of fat. And if you have a fat person wearing the vertical line shirt, then he will be like a thinner. So it really matters. And the building so. So here, if you see the Empire State, there are vertical lines. Even if this gate and this Madrid, Spain skyscraper, they're all vertical lines. If you are seeing about the horizontal lines, this community center or this building is based on the horizontal lines. And if you go for the diagonal, so we have number of bridges or ziggurat or pyramid. These are all showing our diagonal lines. The moment you see these buildings, there will be an impact on your mind in a different way. So the color. Now, the color has an immediate and profound effect on the design. Even if I wear about yellow shirt or the radium color shirt, then definitely that matters. Where you have to see, where you need to be having that particular color. So even white color reflects, black color attracts, or the heat increases more. So we need to understand it's not only the visual, it's not only the efficiency, but that impacts our mind also. So warm colors and cool colors, what are warm colors, cool colors, and these pictures can show how those things are highlighted. One of the importance of the bindi. The moment you put the bindi on your face, the entire atmosphere changes. Not only the human face, but the entire the area gets the different feel, the aura. That is very important. The color plays a vital role, as you see in this particular of all the four same places, same backdrop, but the feel is different. So act is different. So definitely color matters. And then the form and the shape. When it comes to the form, the 3D, and when it comes to the shape, it's a 2D. So 3D and 2D, one should understand. So the structural engineer has to understand these 1D, 2D, 3D, 4D, 5D, this particular progression, and then they can go ahead. The space, when it comes to the space, yes, the open or cramped or unusual. So somebody wants the column-free space, or somebody wants the columns to be the need of that we will see a little later. But the space really matters when it comes. The texture also matters, whether it's a smooth or whether it's a rough texture. Definitely that matters, and that is a part of the design and the requirement. If the smooth structures and a smooth texture, when you see the glass, naturally it is smooth, and the external metal facades, what we are seeing today, there are about 70, 80 types of facades have come. So there are different varieties of facades, which are even dust-free, which are reflective, and there are so many types of facades that also be a part of the structural system when it comes to the glazing facade. And the rough textures, and if you use the stones, or if you use the different tiles, if you use the laterite, the thing is different. If you use the granite, it's a different. So processing is different. So textures also plays a vital role. And finally, the value, the shade and tint. The relative lightness and the darkness is called as a value, and definitely that matters because the illumination level in the room can be definitely changed if the lighting level, light increases same. Then if you want to control the illumination level, then the value is very important. The value, then you can just see how the building looks with a different value. Now, coming to the presentation, it's a time to create a living future. As I said, post-pandemic, the thinking process is different. We are talking about the living. We are maximum staying indoors or whichever space we are health conscious. We are having the productivity consciousness is different. So even we never thought that we will be speaking virtually, isn't it? The technology has made us explore more, at the same time some kind of limitations, but everything comes under envelope. Now I'm very particular about the building envelope because what is the purpose of the building envelope? We know a building envelope is the component that separates the exterior of the building with the interiors. Now, that is what the enclosure is called. That makes a lot of important role in because that is going to be separation, and there are two stages. The first stage is to understand the environment, what is the surrounding of the building, where it is located, whether it's a Kashmir or Kanyakumari or East Mumbai or northeastern part. So we need to understand that then humidity level, rain level, wind level, sunlight and noise entirely different. So Delhi, I can't have the same building like Hyderabad or Tirupati, or like Kolhapur is entirely different than if we go to Varanasi. So I think that is first part, and the second part, the size, type, and material of the building envelope. So, for example, we need to understand the vernacular architecture. If I'm constructing something in the northeastern side, if I think of a concrete jungle there, then it's going to have a very adverse effect. At the same time, we need to understand the local materials. That is what the greening and sustainability matters. And that in terms of right from the foundation to the painting, every element should be accordingly thought. The building skins influence our emotions and behavior within an urban landscape. You go to the newborn so-called mushrooming cities with the glass boxes, you never identify, or when you can't judge whether you are in Hyderabad or Noida, the buildings are going to be same. But we need to understand the local architecture, we need to understand the heritage there, we need to integrate that in the building. So for me, the floors, walls, roofs, fenestration, and shading elements are the elements. In that, some things are structural elements, some things are non-structural elements. Now, when it comes to the tall buildings, 16700, the non-structural elements are also important because they are all architectural elements which can create a lot of problem if something goes wrong in terms of a wind or seismic. It's not the only saving the structure, but it's the safety of the people. So we need to understand or integrate these both, and then we do it. And it's not new. If you see the structure is a columnar and planar and a combination of both. And you can see this caves, how those people they carve, they will understand the spans, the cantilevers, and how those created the units and how they composed it, how they modulated it. I think we need to learn from these things. And architects, they normally visit these sites and they have the history of architecture. Who designed that, how the concept went behind that. So that is literally to some extent lacking in the structural engineering or civil engineering, where we hardly go into the history of civil engineering or history of the buildings, how that particular phenomena has come, how the design builder is to see. Today we have all these different people, but at that time only the master builder who is to do entire thing. So here, when it came as isolation way, I think we need to again come together and we need to understand how the things goes about. And there are many types of structures where one of this is exposure of this structure. You can see the structure which plays a significant role in shaping the quality and the experience of the architectural space. Now, this is the architectural wonder or the structural wonder. It's very difficult to even say one. So this iconic structure is the architecture. So here, this particular integration or the approach towards the exposed structure is phenomenal in Eiffel Tower. Now, when it comes to the very recent example of Burj Khalifa, which is designed structurally by William Baker from SOM. And then you can see here the requirement of the builder or the owner or that particular the promoter was the in a flower shape, that Himonocalis flower, which is from Dubai. So he wanted that to influence the entire design. So this particular modular Y-shaped structure with the setbacks along each of its three wings provided an inherent stability for the structural configuration itself. And the floor plan then that got reduced when as you go up, and this particular thing is like a sculpted spire. And so for me, it's one of the very best example of the harmony amongst the architectural structures, not only architectural structure, but all the type of engineering, that building services and other things. Friends, we have the types of relationships between the structure and architecture. Mainly the nature of the relationship established between the structure and architecture strongly influences the final form when you start thinking. And these relationships can be cataloged as ornamentation of structure, structure as ornament, structure as architecture, structure except as form generator, structure ignored, and structure symbolized. The structure and architecture as synthesized forms, and structure and architecture as contrasting forms. We'll see quickly what are these things. When it thinks of ornamentation of structure, you can see the modern building. It's not that only ancient buildings are having the structures integrated with the architecture, but now the present buildings also, even modern amenities like airports and other things, they are integrated. And in this type of relationship, the form is derived as an expression of the structural armature with minor visually motivated adjustments. So everything is not structurally involved, but some kind of excitement and some kind of a different requirement they bring it, ornamentation. So structure as ornament. You can see this particular Mumbai airport recently. The relationship features a design process driven by visual rather than the technical considerations, focusing on the visual quality of structural elements and attempting to give them visual prominence within the architecture. So it's a very phenomenal and very important example, and eye-catchy and impressive output. Now, when it comes to the structure as architecture, you can see old buildings or ancient buildings to the new ones. So all the architects, those who were doing these things, they were involved with the structural engineers, and many of them were architects and structural engineers, or they had taken the training in both. Architects used to study the structural engineers to understand the architecture and come together to come. So formative typologies which such as the compressive dome or vault and the tensile membrane are amongst the most structurally efficient examples of the long span structures. Here you can see, I like this Friato's concept, which was in the stadium where he got the system of Jali. So in fact, when I was doing some kind of initial works in the domes and pyramids and Jalis, I wanted to have some kind of funicular loading approach. In fact, I got made about 12-15 years back one Jali in the copper, and which was I was inspired by Friato, and I will just show it. See, this is the Jali in a copper. I went to the goldsmith and I said, I want some 2 feet by 2 feet Jali, mesh, which can because at that time the digital things were not that much in practice. So I got these things done, and you can just see for having these different funicular shells, I can even just go for natural. I go for a plan form. form. I use these jalis, and I invert these particular. I couldn't make this in gold or silver because it's too costly at that time. But still, if I could have done this, it was about weighing around a kg or so. But this is in copper. I could get it at that time. But this helps me to generate the forms that may be different types of domes or walls and format to structures. So with that particular mesh will be put, and then whatever I take the measurements in an inverse form, I put in the system and analyze it, and then I go for the review. That's what I took that theme from Friato, and I could do it, and I'm still using it. So the tall building structural challenges, yes, it's in a different level. We have a lot of challenges when it comes to the tall buildings because of the lateral resisting systems is very important. The wind is dominant. The form plays a vital role, and we have we can see the tall buildings, the structural systems right from the bundle tubes and whatnot, diagrids and all. So here I have tried to see some things, but we must understand, and the architect evolves any form, that definitely the structural engineer must involve right from the day one. Otherwise, that form will not be efficient, and even the form generation is not possible. So that's very important to understand. In fact, I love exposed concrete structures and the facades, which where the structure itself is exposed. And today, if I'm doing something and closing it with some kind of a cladding, that may be high pressure lamination, paper lamination, or aluminum composite panel or glass. Well, I'm just closing. I have beautiful eyes and eyebrows, and I'm just putting one shade. No doubt, looks good, but it's not impressive. I'm not connected with you. If I'm having specs, I'm connecting, but if I'm having shades, then I may be a hero, but it's not approachable. I don't have any connect with the common people. So here, when Le Corbusier came up with the building typologies, many of the buildings are exposed, and at that time he could get it. So the form is generated based on the structural requirement or the structural inputs. So here I would like to emphasize on this particular slide, because the man who helped shape India, and this was in one of the newspaper and the cutting there, I took it, Mahendra Raj, so the giant of Indian construction industry. And we are fortunate, Mr. Abhay Gupta. In fact, he is more acquainted than me because I was in the South. And the way we interacted with him, the way we got, everything from Mr. Mahendra Raj is phenomenal. And still we have that in us, body and mind. So he was behind many structures, but he was very successful structural engineer because of an architect. They both went together. Now here it's a coincidence. This particular is Hall of Nations, designed by Mahendra Raj and conceptualized by Raj Raval. So Raj and Raj, here they both came together, and this wonderful. If you judge the moment you see, we may see that feel that it's in a steel structure. But no, it's a concrete structure. The elements are concrete. So such a wonderful thing, they could do it when the two fields come together. And in fact, I was fortunate to see the bond between the structure and the designer. I visited the Hall of Nations before the demolition of that particular structure. Mr. Mahendra Raj, and just you can see how he's touching the body of that particular Hall of Nations. I saw tears in his eyes when he was going away from there. He was saying, my structure or my structure building's body is going to take, it's not going to go on its own, but we are killing that or removing that. He thought, he was emotional. In fact, I was also emotional. That is the bond between the structure or the architecture and the designers. And we too should have that involvement. Every project of ours, every built environment of ours should have, we should put our soul, and we need to have. But today the irony is, even though the designer passes by his building, he can't even identify whether he has designed, whether it's living, whether it's giving any result, whether the occupants are happy and all. But I think we need to go back and we need to understand that the structures ignored. These are examples of the structures ignored. But friends, today we have the computer design, which opened the new chapter in formal exploration with works from architects, friends like Frank Lloyd Wright. I know he used to just take a paper and just do like this, and then he used to say, "This is my structure." So the formation of the generation was entirely different in his projects, where the structures were ignored. But the required things was done by the engineers and made that happen, no doubt. The structures symbolize. The structure is visually emphasized and allegorically represented. Here you can just see in this particular London's Lloyd building how the forces are going to the gravity and how the lateral resistive systems they were designed. So here the symbolized structures, we can see how that building is resulted in. So here the structure and architecture are the synthesized forms. The coexistence between the form and structure is important, whether it's a statue, whether it's a chimney, whether it's the airport or any building. We need to understand these forms and structures. There are 7 to 8 types predominantly. Quickly I will go through. The first is shell structures. Then we have a tensile structures. In this, textile plus architecture is arch textiles. Here you can see how these long span structures or some kind of structures which are having the large spans. There you can go for this kind of tensile textile structures. These are the tensile. And here we have suspended structures, whether it's some kind of a convention center or whether it's a cable bridge. This you can see our Durgam Cheruvu Hyderabad cable bridge, which is one of the best in its kind and category. So a suspended structure is a type of the architecture that refers to an arc that follows an inverted curve. Arc and arch. The arch actually we'll see a little later, but the suspended table structure model is one of the coexistence between the form and structure. The ribbed structure that we generate and define architectural form, although their structural nature often requires a separate packaging system. With the help of the digital engineering modeling tools, these architectural models can be designed and evaluated simultaneously. You can see how these particular ribs they have used, right from the roofing to skylighting to the seating and the library. So it can be interiors, architecture, structures, and everything integrated together. Now, when it comes to the frame structures, the tectonic pillars, a network of beams and columns that are connected to form the structural frame of a building. And here you can in fact see the many examples, including this airport, and you have Adani's new Shivaji Chhatrapati Shivaji terminal, the new one. These are all these kind of frame structures. So then it comes to the arches. The arch, which is the strongest form, the coexistence state between the structure and the form, where the structure adopts the principle of repetition as the basis for the generation of structure using repetitive arcs and various arches. You can see the rhythm, you can see the balance, you can read all this. It's like a music. When you go through that particular thing, the entire that will take you, mentally and physically. So that's the power of structure and architecture coming together. And when it comes to the folded plates, the potential of the folded plates can be demonstrated simply by taking a paper and then you just fold it and then put it. That takes the load. And it's a very, very simple thing. We need to sit together. The civil engineers or designers, and then what kind of a roofing system we can have, what kind of forms we can have. This can be a very, very phenomenal optimized structures if you do it. So tectonic walls also very important, which integrates the structural systems and the formal characteristics, the external envelopes. columns. You can see how this school building gets the light, and then you have a composition, whites and opaque things. It gives a different field inside, or a bit different atmosphere inside. It's not only the architecture which can create, but the combination of both, it gives a very, very different. That is what interposition, which is positioning where. So here the structure and architecture can be in a contrasting form. The relationship between both contrasts appear in terms of the scale, geometry, material, and texture. It's not only the size and shape, but you can have different materials coming together, making a contrast, and which gives the different composition throughout. Now, naturally, thanks to this all the newest technologies, where you can go for a long span structures where the deflection can be controlled, or deflection can be within limit with the post tension or pre-tension or precast or some kind of high grade concrete and high performance materials. But earlier, when you see the structure in the space, it played a very, very important role. What type of a structural system you are going, and what kind of a area we are getting column-free spaces. Because earlier we thought of having individual spaces, but today we have open types, right? From the kitchen, dining, living is open. Even offices, our IT offices are spread over. It's only co-working space or anything you see. It's a huge area with column-free spaces. So these things also can be done. So when it comes to the structure, sometimes the same structure can be a disruption, and sometimes it looks like a enhancement. You can see this Lions School of Architecture, where even though those things are obstructive, but we that enhances the field. But when it comes to the right side, that academy, those columns, even though that is structurally sound and stable and looks good, but the disruption is more. So we need to understand this. We need to discuss together and go for some kind of things. But here, the structure for maximizing the functional flexibility, the minimum. You can see this Dubai exoskeleton structures. We have two types of structures: exoskeleton structures and endoskeleton structures. When you see the left side, we have the example. There are minimizing the amount of interior structure inside the building can be difficult, but especially with the large scale structures, but that is one type. And if you see the heights, the right side, which is the high techs, we have this convention center coming 4, and convention center, hall number 4, which is structurally designed by our Sriharsa consultants, our own Mr. Sridhar Reddy, who has worked out very extensively the new structural systems in the steel. And this column-free spaces, you can have this like an endoskeleton system. So here, this is designed by us. In fact, this is inch by inch. When you go to Shamshabad Airport, this is one of the biggest stone or flooring showroom, where you have very, very big slabs displayed there. So we wanted to have a column-free space. Then we thought of having the system, which is it's an articulation of the circulation. We need to have anything, anywhere. Even cranes can move in. Even huge machineries can go in, and it can have the display. So this is the need of the entire functionality changes with these things. And if you go to the modulation of light, yes. Today, we are thinking of the energy efficient buildings. Our nature to going to the nature is little increased. In between, we went little away. The nature, and even we can see today's impact of this climate change and what we are natural calamities. I think we were little away from the nature. So again, we should bring in the nature or mindset that we should go towards nature. And this is the example, one of the best as per me. This is the Bangalore New International Airport, where a lot of landscaping is there inside. So these are all natural trees or natural greenery. So at least required level of sunlight, required level of air and water and everything. So here the structure plays a significant role in this context, especially when we consider its potential as a source and a modulator of light. So here, right from when I visited last time, and then it was inaugurated by our Prime Minister, Honorable Prime Minister. But this space and this modulation of light is for everybody. CM to PM, that may be common man to the chief minister to prime minister. It makes no difference, no discrimination when it comes to the natural thing. That's what we need to understand and bring in, and let us enjoy that particular thing. The structure for organization, subdivision, and layering of spaces. So here, one of the most important roles of the structure, aside from providing a building supportive framework, is to organize, to subdivide and layer the architectural spaces. If you see this particular building and the museum, the ramp one way, and the other side we had these freestanding columns which were giving the seating areas, and in some areas the same thing was the part of the atrium. So the same structural system can give the functionalities in a different. So we need to understand how to subdivide, how to layer, or how to organize the spaces based on that. This is our own IIT Hyderabad. IIT Hyderabad on Bombay Highway Road, the structure for a phenomenal effect, phenomenological effect, in fact. So this particular steel structure, and behind that you can see the concrete structure, one of the best example for the creating of architectural effect using the structures, the innovative structures, and just see the atmosphere, just see the surrounding there. It's not like a regular classroom, but the people, the student, the teacher, the visitor, everybody enjoys that. The productivity is more, and it's very, very futuristic, but keeping every energy efficiency which we need. And there are the greenest buildings ever. So I think these are the examples of the generative structures for the regenerative architecture. So this is the T-hub in Hyderabad. You can see how the structural system, the steel structural system, and how these cladding, the cantilevers, integrated design process. Here we need to integrate right from IT, their requirements, the startups, the people, those who come there. It's not that easy. You can't have just any space for anything. If you want to perform the puja, that's a different story. If you want to play, that's a different requirement. If you want to have meditation, something different. Fighting is something. So these are all startups. We need to have some kind of a different atmosphere to be created. So the master builder to contemporary design practice, how you develop. So this 11-story, 3.5 total square feet T-hub is India's largest incubation center, and synergize the startups and corporates and governments and academia, investors to driving and to transfer their changes. So I feel these kinds of structures are the need of the hour to integrate, and to bring the productivity to that extent. But this is not new. This is the right from the ancient days. And if you see, this is one of the temple we are constructing in Devarkonda, about 120 kilometers from here. A lot of Agam Shastra experts are involved in there. So as a civil or structural engineer, I give the stability of the structure, design of the structure, but the entire thing is seen by them, viewed by them, designed by them. So we need to support their requirements. So when ornament and structure become a single thing, strangely enough, the result is the new feeling. So this is what the ornament in the building or ornament in the, so that ornament itself takes the load. And so quickly we'll go through a few more slides which are left. For me, the form morphology is the form and the structure of anything. The morphology is very important, and this morphology must be learned and understood and practiced by architect and structural engineer. In fact, the other domains also, to make the things more sustainable. And so, what is that? The account of form seeks to be a general theory of the shaping powers of the organic structure. The materiality, because today the material development, the industrialization, the advancement is too at a different level. So materiality of the architecture has determined the blood relationship between the design, engineering, and architecture, and so whatnot. So we must understand the assembly of the elements which plays a vital role. And I will just quickly go through this. So 1001 building forms by Frank Coyce, who did it, compiled it by taking the different forms from all over the world, and only 1001 what they are listed here. It's a very small size, and it may not be able to see it, but jet speed will go. So these are the C. You can see the mobile mosaic slab or split columns and window reels and all. But see how those things were combined. What you are seeing is all are buildings, the themes. Just see different structures. That may be monument, that may be building, that may be some kind of motifs or these things. You can just see how the things were developed throughout the world. That even Norman Foster's building is there, Burj Khalifa is there. So these things are to be read by structural engineer. They need to be read by with passion. We need to understand how these. It's not like just column, beam, slab, but the combination of elements. As I started initially, you can just go through these all structural systems, what they followed, how they analyze, how they constructed, what is the feedback, what is the productivity, and there are about the siteless 1001 building forms. Now, a few I have taken from them, and just you can see how these things can be. So here the liquid landscape, there is some animation here, but I'm not doing it full screen, though I think it will not work. But anyway, I will share this with all later. So here the collaborators are very important. Other than structural engineer, other than architect, or there are about 15 to 17 domains who work for this particular these particular type of buildings. The collaborator is very important. The integrated design facilitator is very important. Facilitator is very important. So here the collaborator was Justine, and if you go for this particular wavy things, a park and an aquatics center. So how those waves were formed. And here you can see this tower where the engineer, structural engineer and collaborators and architect, they were involved. The progressive stretching of spacing heights results in the building type that symbolically escapes its own location. So you can see how these variations were brought in. So here the pebbles, how those were composed, and how the heap of stones piled up as a memorial or a landmark. So and you can just see structurally the overhang truss beams that carry the four programmatic elements transmit the load. So for the path of the load is very important. We need to understand the structural system accordingly. You can just see how the slices. People can get any idea from anywhere. It's not so the architects are not that simple. They are very crazy. They get any idea. The structural engineers are more crazy. They can get it done. It's not that. So whatever they give, these people will do it. But the synchronization is required, and then the connect is required. Here you can see the building, the slices, how they gave, and all. The morphology is very important. Leave about the building services and energy efficiency. They are very much challenging, but still, I think the people, they have the fancy ideas, and then they come up with these beautiful structures. And this particular, the collision of 23 spheres of identical radiuses, when those are coming together and infusing together, the productivity is something different. Now you can see how these randomly place the things, and they form this particular structure. Now, for example, Lima Towers is a 16 apartment units within a series of blocks with undulates along a spiral, spinal central axis. Actually, this has to move, but it's not moving. But anyway, the formation of this geometry is based on that. And just see the spinal cord in the between, and then how those things were, outside you see the complications, but everything is on parallel. People live in that very happily. Now, before I conclude, there are about few more slides. For structural engineer or the architect, or in that manner, any designer or planner, the generation of the model is very important, because today we are depending mostly on the digital tools to analyze. So modeling is very important. If you don't model, how can you do it? So another 5 minutes I will take, and I will close it.
Sir, we have time. If you want, you can extend for another 10 to 15 minutes.
Okay.
Sure.
Thank you. So here, when it comes to the high-rise shaping, so basically when you think of any long span structure, so for me, the long span structure, the deflection is a problem. If I go for a tall building, then sway or the drift is a problem. So to reduce that, so we need to have a efficient form. So more usage, because if you go for a tall buildings study, only 60-70% of the buildings are habitable, and above that you use for the machines or some kind of a pinnacle or some kind of a machinery placement or some kind of telecommunication. But when the architect and structural engineer and other fraternity comes together and they generate the form, the percentage of usage of the floors will be increased. Say about 180 floors, if you can use up to 160, 170 floors, I think that is the more optimized form. That is the more efficient form for me, because you can go to reach that particular level. So for this, these twisters or angle twisters or sliding twisters, they are the generators. So you can just simply see the very simple form of a rectangular square. When I extrude it along this and then twist it, this turning torso form. This is by architect and structural engineer Santiago Calatrava, who created this form. So here these forms are, so here if I angle it, this particular form is generated. So here sliding twisters. Then extruders. The twisters is one, the extrude is the orthogonal way, angular way, and the sliding way. So here they are the examples of the these extruders. And then if you come to the rotors, it's a very simple system. If you have some kind of a thing, okay, if you take this and rotate this, then that particular form is generated. So here the hyperboloid, boloids, and rotors. So these are all the, so you can just red curve is the principal curve, and then when it rotated along this, so this creates this particular generation of evolution of this particular form. So it's very important to understand how those forms are developed. And once this you understood, then you can model it, and then naturally the application of load and application of a lot of things, and then it comes as a final result with the involvement of more than 30-35 experts in this. So these are the free shapers, you can see all, and then inspiration from the human eye. The Santiago Calatrava, who is a very different kind of a, so he compares the human skeleton or animal skeletons, or basically he was a brother of a veterinary doctor, so he used to observe a lot of animal skeletons, and you can find many of horizontal elements rather than like our spinal cord, because the animals, they have a horizontal. So here he took the inspiration from the eye, and he created this particular eye of knowledge. And here the twisting torso, as I said, his own figurative sculpture. He tried to make that. So you get the idea. So here, even myself or and the people, those who are architectural structural, we create some kind of a different modules. But when it comes to the entities, say for example, different architect and different structural engineer, we must come together right from the day one of the conceptualization on the board, so that you can come up with different ideas. If you ask architect David Fisher, he will say the right from the, or James Law, those who are cyber tech. In fact, the cyber tech, the James Law makes his cyber people to sit together, because he uses a lot of digital equipments and digital supports in his building. So we need to have expertise. If you want to make something rotate, then definitely mechanical, automobile, and other experts are required. So here, the integration is important. When you come out of the college from the structural engineering, we must understand what other role is there. Otherwise, you will be doing, but what about others? So that integration is very important. So here you can see for us, when we conceptualize this Ramanarayanam, the Dhanush was the Dhanush and Bond. That was the inspiration. So which was conceptualized and approved by Bapu, the very popular producer and director of the mythological films. So the one thing is opportunity. The other thing is we need to organize in a proper way, so that everybody will be having their say and other things. So here I will I will give only one example of one of my project where I am very, very, fond of, or that is under construction, in fact, but this is the world's first of its kind building in terms of functionality, where the testing of the infants in terms of their hearing challenge, that they will be testing it. So here, friends, we have more than few lakhs infants, those who are not treated or diagnosed in their first month about the hearing, so they can't be repaired. But if those people, they can come here, and it's a very I mean, what to say, a charity trust, and where it's nothing to do with the money, but they can come, they can get the infants hearing tested. So it's a SAI, which is the Society to Aid Hearing Impaired. It's a world's first center. In fact, it's coming up in Visakhapatnam, and I was fortunate to do it. So I had in discussions with the ENT specialists of various hospitals from the country, and they came up with the ideas. In fact, they are not done, but they are doing advertisement, although they are the ambassadors for this particular thing, and many people there have implant also. But here I got the idea from the spiral, which is the golden ratio, the beautiful asymmetrical found in plants, animals, insects, and other natural structures. And this particular mathematical phenomenon is called as a golden ratio, also known as the divine proportion, the golden mean, or the golden section, the shape of the golden spiral, one of the more appealing shapes, pleasing proportions found in the nature, that is 1.618. So the number and the ratio itself is derived from the Fibonacci sequence. We can just try this at your time, leisure. So it's a very wonderful ratio which comes out, and that you can find in the ear and everywhere. So I took this concept, and I created along with anatomy. So because the human embryonic development refers to the development and the formation of the human embryo, and how that first month to the 30th, and first week to 30th week, that is part will conceive to the delivery. So that also has the shape. So with all this anatomy, I considered that, and I came up with the form which was impressed by then, and they cleared it, and then this is under construction, and you can see the shape itself gives a little. We felt the problem with the torsion, but we could handle it with the proper structural design. And then here we had without fins, with fins, because it's in a Visakhapatnam hilly area, the humidity level is more. So instead of a circular or another shape, this is giving a more shading, and we got this as a 6-star rating. And you can just see this was at the design stage. We could analyze it using the simulation softwares and other calculations, but we could get 6 stars for this at the design stage. And this when we started on the hill, so within 6 months we could come to this stage now. So architecture inspired by anatomy, this was in my case, because I always compare the human body and building body. So just to cut the monotony, I would like to take you to another inspired world where the architecture inspires others. It's not that architecture always takes the inspiration from everywhere and do it, but architecture also gives inspiration to others. And one of the sector is fashion, clothing. So how that inspired? So if you can see this Del Piero in 1927 film Metropolis, that Del Piero, who is the test designer, got that idea and come up with this particular test design. And here you can see Rosie, who took the inspiration from Italian architect Carlo Scarpa from their building. And then you can see the design output. Then the Frank Gehry, as I said, Frank Gehry, there is and no form at all. Any form you can put. This was the inspiration, and then a very different type of architecture, and which went behind this trace design also. Zaha Hadid, yes, one of the finest leading architect of the world, where the forms were different, fee forms were there. The generation of forms was a phenomenal idea, and the people, those who made that happen or reality, really hats off to them, because execution is also important. This particular Zaha Hadid project, inspired Millie's dress output. And this is another Japanese film where the Mason got inspiration to bring out the design on the T-shirt. And here, landscape architects, the landscape also inspires the dresses. You can see which is the dress and which is the landscape. We are not able to even identify. So here, this is the jeans, and it's my very common slides. The earlier mindset about 30 years back used to wear jeans like this without any fold and all. So use of jeans in different form at that time. But today we have a different mindset. The present mindset uses the ripped jeans, which is correct or not, I don't know. But how this got, which dress designer designed this, I don't know. But when I was thinking, I thought that this designer would have sat in front of this distressed building, and then he got these ideas and he developed this particular thing. So inspiration of the buildings, even distressed buildings, dilapidated buildings, brought this innovative way of dressing. I don't know whether it's innovative or what innovative, but form follows function and function follows human behavior, which is the new normal. But friends, the lower part is very important to understand. This particular arch is inspired by the nature. This is architectural structures example, but for architects, inspired from the nature, but the sun path is very important. The architects keep sun path in mind. This is my own house where I use a lot of skylight, in my buildings and even in my own house. It's a net zero building. So I play with the light of daylight and even with the light, artificial light. So sun path is important for architects, load path is important for structural engineers, but both the things are important for all the fraternity. But when you go to the childhood, keep entire my presentation aside, we used to play this. So let the new generation also try to play this. New generation, they are on the screen time and they do the digital thing. But kids, make them learn something at the sand. Let them learn something at the grass. Let them know something with these kind of structures. Otherwise, it's very difficult later. So conclusion, architecture and structure is a collaborative process. The interplay between the structure and design, the layering of the process and diverse but intertwined approaches to conceptualization, analysis and construction emerge as architect and engineers delve deeper into their fundamental base of knowledge and renegotiate the boundaries between their disciplines, understanding the architecture as understand the architecture as structural imposition or the structure as architectural interposition. So we can change both structure as architecture or architecture as structure. It makes no difference. But once I congratulate Triple IT for doing their events good, and a happy Engineers Day. Naturally, it's one day before, and we have that tomorrow. The science is about knowing, engineering is about doing, but the architecture is a visual art, and the buildings speak for. So he was one of the master builder of the 18th and 19th and 20th century, and he will be remembered for the centuries coming ahead. Thanks a lot, each of you. Thank you.
Thank you, sir. Thank you so much for the wonderful presentation. Shreya, over to you.
Yes, sir. Thank you, sir, for your valuable insights and warm words. The concepts presented today provided a deep understanding of the relationship between architecture, structure, and also the environment, highlighting the functional aspects of the building design while acknowledging both aesthetic and emotional responses they evoke. Your expertise and thought-provoking content has left us with greater appreciation for the role of architecture in shaping not only structures but also urban experience. Thank you so much. And now I would like to have now we are at the concluding segment of our webinar, where we are open to receive questions from the participants who are eager to discuss with you, sir. And I would like to have Dr. Praveen to proceed with the Q&A session.
Thank you. So there are few questions which I'll read one by one so that we can discuss. So
Okay.
there is a question on how do architects choose the geometry, especially size and shape, for constructing the civil infrastructure?
Yeah, basically, if you see all the properties which are given to the architect to design, basically that starts from the shape of the plot itself. Say, for example, the land, where you are going to construct. It's not always the shape required, but sometimes you can see see different buildings of different sizes. But at the same time, as I was saying, the forms depends. Depends on the requirement. And obviously, say for example, our cyber tower is circular. Why that is circular? The pyramid structure is in that other shape. So it's a requirement of the people or occupants, those who come to have that. So basically, even if I get some work, as an architect, they come up with the requirements, and then we generate the forms, and those forms are optimized by the structural engineers. So for example, if I'm coming with this convention center, for convention center, what I need, the number of seats, so if you are going for even theater, so I need the functional utility, but the form follows function, isn't it? I need to understand what only form follows function, but today we have some kind of a attitude also. No, as I was saying, earlier it was like that, but today it's not. You can't even identify whether it's a temple or it's a mosque or it's a IT building. But the form is generated based on the requirements and the functional usage, and that can be optimized and that can be taken further with the help of the structural engineer to get the real things happen.
Okay, thank you, sir. The next question is there any difference between how the structural engineers design a structure and the way how architects design a building?
Wow, very good question. Friend, structural design is different. Architectural planning is different. I will explain in a very, see, Mr. Abhay Gupta is there. If I ask him what is 5 plus 5, he will be saying 25. Even if you are a professor, he will say 5 plus 5, 25. Even our host, she will say that it's 5 plus 5, 25. But if I say what color you like for your building, you will say green, or the same area. If I ask everybody, one will be saying smooth texture, some will be saying the glossy texture, somebody will be saying rough texture, somebody will be saying I like red on this, or somebody saying white on this. So that is architecture. The first one is engineering. So how can you think? The structural engineer's job is entirely different. The architectural plan is different, interiors plan is different, and the structural plan is different. You can't do it, but it's not. That's what the master builder who used to do entire thing right earlier. But here, structural engineer can plan it, but it's not only planning. We need to have grouping, circulation, orientation, aspects, prospects, material science, whatnot. And the total life cycle of that particular building is important, but the functional life cycle is very important. So adaptability is very important. If I'm using something like a seminar hall, the resounding will be there. It's not. So you may be having a correct. That's what I'm saying. Every good-looking thing is not correct. Every correct may not be looking good. So when you come together, everything will be good.
Okay, sir. The next question is, I don't know whether you'll agree on this or not. Why don't the architects and structural engineers trust each other, even though they often collaborate and depend on one another? Is it because of the training and priorities or something else?
I think Mr. Abhay Gupta can give you answer a little bit, but see, what happens is, it's like an anesthetician and surgeon.
Okay.
You have to understand your role. See, if I am doing surgery, I need to concentrate on surgery. If I want to give anesthesia, I need to give. So we have to have roles. It's a combination. So for example, my mobile phone, it's not only made by me. There is a plastic industry involved, chemical industry involved, electronics involved, software involved. Here, there is no integration. See, in fact, I'm just a little bold about you. IIIT Hyderabad, electrical engineering or computer engineering division people or students, when have they visited the ERC? Or You go inside and ask where is the ERC, they may be knowing, but what is happening within the do you think that earthquake resistant building is only for civil engineers? They must know, no? So that is we are isolated within the campus. We are isolated.
Right.
If my body is not integrated, if my hand is going this side and my leg is going this side, then how can you go? So this is a part of this. We need to understand. So it's only the mindset. We need to come together. That's what these all huge structures. When I spoke to David Fisher, who is in a dynamic architecture, who comes up with the different, circle, revolving structure. I asked him, at what stage you invite all your other people? He said, day one, if my thing is to move, then we need to have automobile engineer, fixtures, aerodynamic, all the space designers. So everybody, about 15 to 16 top notch. The people, the person who is doing design Ferrari, he was supporting him. So right from the day one, are ye kar sakte nahi kar sakte? See, if I'm starting, even if you're going towards a small lane, we will ask whether this lane goes there, but whether my car goes there, whether I have to go by walk, or whether to take a different route. So I think we need to have training, and the teacher's role is very important right from the first day. What for we are going to see? It's not industry ready means you know everything. Industry ready means what is the requirement of the society, what is the required. Serving others is the motto, and it's not to serve ourselves, and it's not only software. Without software I can't do it, but I need to know what is the input I have to give. So here the mindset has to be there. The such training is required right from the schooling itself.
So I think this misconception may have arisen maybe due to the competitive pressure or due to the concerns about liability, and there are several other factors.
I don't think so, Dr. Praveen. If I compare with the medical, I'm not arguing here, but medical profession. If you go to a village, there is a person called RMP PMP, registered medical practitioner or private medical practitioner. He is a god there, yeah. Right. What he does, he gives the preliminary thing, and then he comes to the district, and then he comes to the metro, mega city, or he goes to the other things. So here everybody is important. It's not that Mr. Hafiz contractor will design a small building in a village, isn't it? So we need to understand. So all are going to be trained. When you are driving, use your things. So codal provision, codal provision are there, but who is integrating National Building Code? How many of us has having a National Building Code in our office? How many? So I think right from the education level only it should change, and new education policy definitely is going to change to some extent.
Okay, sir. Thank you.
And that is what our institute is there. Our Indian Association of Structural Engineers, or in that way we IIA, we need to struggle hard with, and that is one of the exercise what we are doing today.
And your answer have highlighted also that how do architects and engineers must work together, right? So my next question to you is, what role do you think the artificial intelligence and the computational design will play in shaping the future of structural architecture? Your perspective, sir.
Very nice, very nice. See, when I was thinking of, say, for example, this, I created this particular jali to create the parametric design. Okay. Now, if I, so you can just see this, the shape, the size, the opening, the curvature, this is parametric, isn't it? Right. Now, this particular thing can be done virtually or using digital or AI very easily. You can create some model, you can give some virtual load, and then you are getting that shape. So it's going to be a different. As I was saying, right from the log table or slide rule, we came up to here, and it's going to be very, very. Even yesterday I was talking to somebody. It's a computer-aided stitching. I earlier used to have some kind of embroidery. What he says, you just write it, scan it, give it, then stitch it. So stitching is going on. So 3D stitching or 2D stitching or 3D ornament making. So it's a small element, but building is a big element. But I think all things are going parallel. So you need to utilize those AI along with natural intelligence and human intelligence with correct balance. It's not only 1, 2, 4.
Okay, sir. There is a question on this golden ratio. Is it the same what you were referring to, the ratio between the two
Yes.
entities?
Exactly. We have, see, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, like that it goes on adding.
Goes
And
on.
when you join that, that becomes a spiral, golden spiral.
Okay.
That's the golden ratio.
And the ratio of these two entities comes out to be approximately
1.62, yeah, exactly. 1 is to 1.62.
Okay. So the next question is how an architect takes an inspiration from a natural things like leaf, LEF, leaf of a tree, and how the final design is shaped.
Yes.
Any thoughts on this?
Wonderful. We have done a few projects on that. See,
Okay.
basically, when I close my eyes, every building is like a tree, isn't it?
Right.
Because for even structural engineer, every tree is a building. Because the building is fixed at bottom, the tree is fixed at bottom. And the trees are different. And when you compare the cross section, you will understand that. Whether it's in seashore, trees are different, and Kashmir, the trees are different. So here, the leaves also, how that, cantilever. So the more you, and every leaf, so for example, lotus, the creation of lotus, the creation of any leaf. So either that is the shape of the leaf or the bunch of a leaf, that particular thing influences the designer to think the form, the shape, the network. For example, that is what I'm saying. An architect, when he starts, he makes the elements to bring object, but the functionality is important. In that, traffic, internal circulation, grouping, then aspects and prospects. The aspects and prospects are very important. When I look outside, how the things are there. When I look from outside to inside, how the links. So prospects and see, I am good, but my surrounding also should be good. The surrounding is bad, but good, and I am not good. There is a thing. So it's an integration. But definitely, every form, every curve that you use. See, basically, if you go to the urban design, I'm not talking about a building, but if you go for urban design, the networking of the roads, otherwise you see the fiber towers, it requires about half an hour just to pass that particular tower. But if you take a leaf, very complicated, if you try it, बचपन में हम लोग करते थे ना, you used to take a leaf and place in the book. We used to have just see the networking. So you can learn the networking from the leaves, and you can apply in this, and that is the facade also. I did parametric design using the leaf, dried it, and those formations we did it in the this one. So that's the beauty of it.
Wonderful, sir. So the last question of the day, how the relationship between the modern architecture and structural design will get affected in response to the challenges like climate change or urban densification?
Very nice question. In fact, last 3 days I was in the jury of Energy Efficiency Awards, where we were thinking of carbon neutrality. So leave about the net zero building in terms of energy, but we are talking about the reduction of the carbon footprint. So so somebody says, well, what is my role in that? So the structural engineer plays a vital role in the reduction of the embodied energy itself. Because if my structure is accordingly, then usage of steel, usage of the concrete, usage of material, if I really optimize that perfectly, then I can reduce the embodied energy. So with the invent of these materials, these new technologies, and this, for example, we used to have, there is a difference between the steel structure, which is made with the I section, L section, or C section, C channels. But there is a drastic difference if you go for the PEP, because I know that I'm cutting the sheet and I'm making my own forms. So there is a difference between the steel structure regular and the structural steel and this PEP. So like that, precast, yes, we can have different forms. In fact, why our column should be regular? Why my form of the column should not be like a tree? Because we are not able to make that. So today we are able to print that. I think tomorrow Mr. Abhay Gupta will come up with the structure which is like a tree only. I think, in fact, after me, he has to give some view, because he creates the statues and a body. I'm not able to create the human body, but they're also failure. I think our one of the team is in Mumbai to study the Shivaji Chhatrapati statue collapse. So that can also happen. I know. I never thought that such a big statue also can fail. But so anything can fail, but we need to take it as a challenge. So this entire thing, we need to be very careful about the codal provision, and tomorrow we are thinking of performance-based approach. So I think software is a tool, teachers are a guide, and education is to create our foundation. But once you come out, the integration is very important, and all the domains are important in terms of the building design, because I'm designing temple, I'm designing airport, I'm designing hospital, I'm designing hospitality, whatnot. So every part function is different.
Right.
Based on that, loading is different. So AI is going to make a lot of change, and I think integration can take it further. Over to you.
Okay. So there is one small question asked by Mr. Faisal. Do you think, as an architect, there is a building in Bombay which is called Antilia?
Yeah.
Antilia building.
Antilia, exactly.
Yeah. So it is worth the amount spent on it based on its architecture.
No comments.
Yes.
See, actually, if I want to wear the Kohinoor diamond, it's up to me.
Absolutely.
That's all. Very simple.
Right. Right.
See, what kind of a diamond? If I want, I can go for a plastic diamond also. I think there is no comment. But as a structural engineer,
Yes.
as a requirement, I mean, before I will go for a different category. If I design the say command control center, I need bulletproof glass or the security or protocol. So everybody's protocol is different. We are the people. We have to. That is what socio-economical. Those are other side of the coin. But from this side,
True.
I think our thing is to deliver what they need. Thank you.
Right. Right. Thank you. Thank you so
May I
much,
have a
sir.
Yes,
Yeah.
sir.
Yeah. Please, sir.
First of all, full appreciations to Dr. S.P. Anchuri. Fantastic lecture. He wonderfully took us through the journey of various forms and structure connected with that. Really wonderful collection of the buildings and the architects and their works across the globe. Very nice to listen all that from you. So thanks a lot. And I'm sure that the students will think that even if they become structural engineers, it is not a focused window, but rather an integrated solution, which we all need to learn. We need to think that all these stakeholders have to work together in unison to create a sustainable structure or a building.
Right. Right.
So whatever has been done worldwide by renowned architects has been very well presented by Dr. Anchuri. Thanks a lot for such a wonderful presentation. And I'm
Thank you.
sure that in our country also, we will have structural engineers who will really come out of the software and first develop a thinking about the form follows the function. That is very, very important, because it is true that all these software are tools only, and whatever conceptually you learn and think, that leads to a creativity. So from my side to all these students, that please read about all these good things and relate your creativity to the nature, and then I'm sure that the latest new development of the materials and the software tools, I'm getting exposed nowadays to the parametric design, uh, parametric software, which are uh, really taking care of some of the wonderful shapes of the buildings, so that parametric design is getting important. Some new materials are there. Recently, I learned about UHPC, and in some projects we are thinking to implement those UHPC as a material also. So those things, but certainly these type of lectures would be very helping while we develop our younger generation. Thank you, Dr. Anchuri. Fantastic.
Thank you. Thank you.
Before I go conclude, I mean, Mr. Venkat, here I just focused on the mindset or thinking
Right.
process of architect and structural
Absolutely.
engineer. But the structural engineer's role to educate an architect is lacking. I'm just straight away I'm saying, because when architect designs, he never knows what the structural system should be, whether it should be in steel, whether it should be in concrete, whether it should be in hybrid or precast. He is hardly bothered about that at that stage, and the new generation leave over. And if somebody is occupying, so I don't know where, in what building you are living, in what building I am living, but they feel that it should be safe and durable and affordable and then handy. But here there are so many new structural systems they are coming, but architects still they think that RCC or some kind of a regular structure is good enough. So we are teaching the same thing in the colleges, and we are limiting ourselves to there. But today, PEB is not taking up, precast is not taking up, or some kind of a systems they are not, leave about 3D printing. We are talking only about 3D printing at a different level. But why? Who will accept it? Who will do it? That's a very different story. And we have Mr. Rishabh, who is from Instack. I think Rishabh, the same Rishabh, I don't know. But if he can put something, because structural engineers must understand, and they should be specifiers to the architects, in fact. They are not subservient. So we think that अरे हम लोग तो आर्किटेक्ट के नीचे काम करते हैं, ऐसा नहीं होता है. आर्किटेक्ट तो स्पेसिफाई करता है. वो स्टेज में अगर हम जाएंगे तो वी विल बी डूइंग इट. यस ना सर? आई मीन हमें वो लेवल आना चाहिए कि भाई आर्किटेक्ट को जो हम बोलते हैं वो करना चाहिए. दे शुड बी लाइक स्पेसिफायर. सी देयर इज आर्किटेक्चरल प्लानिंग, स्ट्रक्चरल planning, then architectural designing, structural designing, execution, then it comes to the operation. So I think we need to change the structural system itself. If Mr. Rishabh is there, I think he can put some.
I think this Rishabh is an MTech student, sir. I think.
Okay.
Sir, there is one last point. There is one participant who has asked a very interesting question. This will be the last. So what are the new trends or the policies of government to focus on the design of building for climate sustainability?
Great.
And how can we overcome the thermal problem of structure? So AC must be very less, which also reduces the carbon footprint.
Yes.
Any thoughts or your perspective?
Yeah. See, it's a good thing that he asked that, because I'm part of energy efficiency of the code. So we have this ECBC, Energy Conservation Building Code, but it's going to be soon ECSBC, Energy Conservation and Sustainability Building Code. Now, we have very clearly mentioned in that in 1 or 2 months it will be coming out. So what kind of U values are required for the walls? What kind of U values are suggested for the roof? And in fact, Telangana is the first in the country to go for the cool roof policy. We have very, very good policies, and I was instrumental even to bring that cool roof policy along with others, where your ceiling, the top slab, how it should be, and what reflective coating we have to give, or what kind of a power roof we can have, what kind of a green roof we can have, what kind of a cool roof we can have. So what are the thermal requirements, what type of insulations we have. So that's what it's an entirely different subject that depends on the envelope. External. One is structural system, the other thing is envelope. Now, envelope plays vital role to create the indoor atmosphere to the comfortable level. Some things are passive, some things are active. So, passive things are at a design stage, active things can be later, like air conditioning on. But the structural engineer can do a wonderful job by adopting new techniques like thermal insulation. So you can have, you might have heard radiant cooling. So we are using radiant cooling in few of our slabs. In fact, it's getting reduced about 25% energy efficiency and this power. So even if you have geothermal systems, which we utilize the temperature of the ground or earth to maintain the inside temperature. So there are there also, see, it's not only architectural structural integration, but we have building services and others. It's a very big topic, but as such, I will share some kind of inputs to you about this sustainability code, which is going to come from Bureau of Energy Efficiency, and it's a part of a national building code. In fact, there is a new chapter since 2016 for the sustainability. Please go through it. Very clearly, they have mentioned what kind of a shear walls or what kind of a hollow core slab, or what kind of a performance concretes, how they are, or green concrete, how they can introduce, what are other alternatives which can be done. But it's very much clear the role of structural engineering to bring the efficiency more in the building is there.
Thank you. Thank you so much, sir, for clarifying all the doubts and answering all the questions of our participants. Shreya, now it's over to you.
Thank you, sir. Now, I would like to have Anshika to deliver the vote of thanks.
Good evening, everyone. I am Anshika Chaudhary, pursuing MTech in Computer Aided Structural Engineering at IIIT Hyderabad. It's my honor and privilege to deliver the vote of thanks on behalf of the entire Executive Committee of ISTRUCT IIIT Hyderabad Student Chapter for this insightful webinar. First and foremost, I extend our deepest gratitude to our esteemed guest speaker, Dr. Architect Engineer SP Anchuri, for his insightful presentation on structure as architectural interposition. Concepts such as regenerative architectural, integral components of designs, building in envelopes and their significance, and different functionality of structural space were particularly very interesting to learn about. Moving on, I would also like to express a heartfelt gratitude to our faculty advisor, Dr. Praveen, for his continuous guidance and valuable suggestions throughout the planning and execution of their webinar. A special mention goes to IT team for ensuring seamless technical support and to the design team for their creative inputs and logistical assistance. I thanks our program coordinator, Dr. Sunita Palisari, for her continuous encouragement. I also want to express my appreciation to all the participants for their active involvement and thoughtful questions, which enhanced the discussion and made this webinar a collaborative learning experience. Lastly, I would also like to acknowledge the hard work and dedication of entire team whose collective effort has made this event a success. Your commitment to bring quality education experience to our chapter is truly commendable. In conclusion, I extend my heartfelt thanks to each one of you for your participation and engagement. This webinar has not only deepened our understanding of structural design in architecture but also strengthened our community. We are extremely grateful and look forward to your continuous support in our future initiatives. Thank you, sir.
Thank you. Thank you.
Thank you.
Thank you.
Thank you so much, sir.
Bye. 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 Bye.